Okay, this is identifying transformations. So kind of a review of what we have already learned minus the dilations. Make sure that you write everything down that I write. Ask for a highlighter if you need one. Stop the video at any time that you need to play it back or have time to write the notes. Anytime you need to, you just pause the video, play it back, whatever you need. Okay. Use what you've learned so far to identify each transformation given both a verbal description and an algebraic representation of each transformation below. So, number 1, we have, first I want you to highlight the original image. Okay, which is also called your pre-image. And we know that because the prime, the new image, is going to have little tick marks beside it. So we know this is our original, and this is our new. But it's also our image and our pre-image. Okay, those are terms that we've already learned and gone over for certain things, but I just want to make sure that you're understanding. So with the verbal description of what happened, okay, they are congruent, same shape, same size. So it's not a dilation. Like I said, this will have no dilations on it. But what happened to the figure? It reflected directly over your x-axis. So it is a reflection, like looking in the mirror. It's going to reflect your image. It's exactly the same amount away. 1, 2, 3. 1, 2, 3. Okay, your B is where B is, but it's just reflected over the x-axis. So we're going to write reflection over the x-axis. It is a reflection. So the algebraic reflection, remember we said there were rules on your xy. So your original xy reflected over the x-axis would be x negative y. The only thing that changes is your y becomes negative. Therefore, it reflects over the x-axis. Number 2, highlight your pre-image or your original image. Remember, it is the one without the tick marks. Please highlight that. And now we're going to have a verbal description on what happened to the image. If our image started here and it came here, everything, if you'll notice, your vertices have changed directions. Okay? When the vertices change directions, this one's down, this one's up, it's going to be a rotation of some sort. Okay? So remember your rotations. If we start here and we rotate clockwise, you're going that way, the direction of a clock. Counterclockwise, change the color here. If it went that way, it's counterclockwise. It would go opposite of what the clock goes. Okay, again, this is just review. We've learned all of this. So on this instance, since we know the vertices are different, we know that there was a rotation. And because this rotation is directly across, it's either going forward 1/2, clockwise 1/2, or backwards, which is counterclockwise 1/2. And 1/2 of any turn, if we know a full turn is 360, half of it is a 180. So it is a rotation (180°) clockwise or counterclockwise. So we could say it was clockwise rotation of 180 or a counterclockwise rotation of 180. When it's a 180, it doesn't matter because it's going to end up in the same spot. And for the algebraic expression, you're going to have your x, y. It's going to become your negative x, negative y. Both of them flip. So your xy becomes your negative x, negative y. Okay. Number 3. If we look at this figure, I want you to highlight your original figure. Highlight your original figure. And then we're going to say, what happened to that figure? Out of all of our transformations, this one we usually call it a slide because our letters are in the exact order. The vertices did not change. It is congruent, same shape, same size, congruent. Vertices are in the same order. So it simply slid up and over. Okay? It slid up and over. So that's a translation. Nine units left and 8 units up. And we call that a slide. But it is a translation. Trans really means it's a movement, trans. So translation is we're sliding over. So we went 9 left and 8 up. Or we could have gone 8 up and 9 left. We would have still ended up in the same spot. So your algebraic expression, your x, y, becomes x minus 9, y plus 8. Okay, because when you move left, that's a negative. Okay, if we're moving from here to here, going left, we're getting into the negatives. So this would be x minus 9, because this is our x, this is our y. Okay, so our x would be left 9 times, so that's x minus 9. And your y is going up, so you're adding 8 to whatever it was. Okay, make sure you're filling in your notes. Number 4. Well, let's look what happened. Same shape, same size. It's congruent, but it's not reflecting because it doesn't look the same. It did not reflect. So you have to decide, was it a rotation or a translation? And if you look at the vertices, again, highlight your original. Highlight your original. Now look at the vertices. N is here, N is there. The vertices changed positions. When your vertices change the positions, it means there's going to be a rotation. Remember, rotations are when we use the patty paper. Oh, I gotta get a different pen for that. Use a pencil. Okay, and it's always about the origin. It rotates around the origin. So I'm drawing my coordinate. Put my origin there. We're going to trace your original. And then I'm going to see what happened to it. If I move it clockwise, going in the direction of a clock, I'm going to hold my pencil there. I'm going to rotate my paper clockwise. And with it still on the origin, it's going to lay on top of that new triangle. Same shape, same size, but it rotated. Now, if it rotates just one rotation, that would be a 90 degrees clockwise. So from here to here, 90 degrees clockwise. Now, if we rotated it backwards, which we can, if I go back to my original, I lay it here. Okay, I'm going to rotate counterclockwise 90, 180, and 270. So if I did counterclockwise, if I went this way, it is a 270 degrees counterclockwise. Now then, we just have to write that down in verbal description. But I needed to show you what actually happened. So verbal was going to be a rotation. (90 degrees clockwise). Put a clock W. Or a 270 degrees counterclockwise. I'll shorten it a little bit so you don't have to write so much. This is just a review. You're going to have a quiz tomorrow. Quiz tomorrow. Okay, so what happened to the algebraic representation? Your original x, y, what happened to it? Well, your y came first, and then your x. So y, then opposite of your x. So when it rotates 90 degrees clockwise or 270 degrees counterclockwise, your y will be first, and your x will become negative. Okay, looking at number 5. I want you to highlight your original. Highlight your original figure. And let's look what happens. Same shape, same size, so it is congruent. Okay, so it is congruent. And look at your vertices. Vertices are the same. Vertices are the same. So it did not rotate. If the vertices are the same, it did not rotate. So if it didn't rotate, it looks to me like it well, it can be a translation. It slid over because your P is still in the same spot, your Q is in the same spot. Okay? So when your vertices are in the same spot, it is a translation, which we call a slide, but translation is the correct name. So we're going to say it translated, the translation, and then we have to decide how many times did it slide over. So from Q to Q is what we're counting, or let's do it down here, O to O. So we'll do it in a brighter color so we can see it better. O to O went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So it translated 10 times to the right. Okay, it translated 10 times to the right. Your vertices are the same. So your X, Y became your X plus 10, and your Y stayed the same because it slid just only to the right. It didn't move up and down. Okay, number 6. Let's look. I want you to highlight your original figure. Highlight your original figure. And then look, what happened to that original figure? The vertices are in a different order. If we try to slide it, they'd be in a different order because the V and U would be over here. So that means they reflected over the y-axis. There was a reflection over the y-axis. If it were to rotate, if I rotated my paper, that figure, the new figure, would be pointing down, or vice versa. So original figure, if I rotated it, it would be pointing down, but it's not pointing down. So it's got to be a reflection over the y-axis. So your original xy becomes negative xy. Okay. Remember, you can stop this video at any time to catch up on your notes. Go back, listen to it again for review if you're not understanding it. Okay, let's look at the back. You're not going to work with a partner. We're just going to do them all. Okay? So, we are going to describe what happened by the algebraic expressions. If you need to, you can come back and look at what the rules were that we wrote down. And that's going to help you because these are your rules. Okay, so if we look at the first one, your x and y became x plus 10, y plus 5. I'm going to tell you that the x and y location, they didn't change. They didn't become opposites or anything. They slid to the right and then they went up. Okay, so that was a translation. Ten units to the right. and 5 units up. Okay, everything was positive, so it went positive. Number 2. XY became negative X, Y. So that was a reflection over the Y axis. Number 3. You have XY went to X minus Y. Okay, so just opposite of what we just did. So that would be a reflection over the X axis. Reflection over the X axis. Number 4. XY became Y negative X. That is a rotation, 90 degrees clockwise or 270 degrees counterclockwise, which we did on the front. Make sure that you are writing down the transformation. Okay, I'm telling you what it is, but you have to write it down. If you have questions about anything, look on the front, flip your paper over and look there. So number 5, you have XY is going to turn into an X negative 2, Y negative 1. The XY stayed in the same order, nothing happened to those, except we're moving 2 to the left and 1 down. So that would be a translation of 2 units to the left and 1 down. That would be a translation, 2 units left and 1 down. Again, you're writing this in the column under where I started to verbally explain what's going on. Number 6. Your XY becomes negative X, negative Y. Okay, if you looked on the front, something that just totally went opposite, that would be a rotation of 180 degrees clockwise or counterclockwise, because they're both totally opposite. Again, pause the video as needed. All right, it says get a spinner, a paper clip. We're not doing that. We're just going to work through them, okay? So let's start here at point A. Point A is negative 9, negative 3, is translated 4 units to the left and 2 units down. What is A prime? So, 4 units to the left and 4 units down. Okay, we have our X, Y. It is translated. So you're going to have negative 9 translated 4 units to the left. If I go left on a number line, it's negative, right? So we're going to subtract 4. And then my negative 3 is my Y. And it went 2 down. So on the number line, on your coordinate plane, when you go down, that's another negative. So you're going to do negative 2. Then you're going to come over here You're going to do negative 9 minus 4. That will be your x. And then negative 3 minus 2 will be your y. Let's look at point B. We have x, y. And I'm just going to put these over here so you know what your new coordinates is. For B prime, negative 5, 5 is reflected over the x-axis. Where is B prime? Okay, so what happens when it's reflected over the x-axis? Okay, look at your rules. X, y becomes, when it's reflected over the x-axis, your y goes negative. So it's going to be x negative y. So your B prime, follow the rule, would be negative 5, negative 5. That would be your new x and y. This is the rule that you follow. So substitute those in, and you'll see where I got that answer. Okay, let's look at point C. C is 7, 6. It is rotated 180 degrees clockwise. Where is your C? Remember, when you rotate 180 degrees, your x, y becomes negative x, negative y, which would also mean opposite. It's just an opposite. So your new xy would be negative 7, negative 6 for C prime. Point D. You have your xy is negative 8, negative 1. It is reflected over the y-axis. Okay, so your xy becomes, should be negative x, y. So it should be opposite of what your x is. And that would be D prime. So you would take the opposite of your x and leave your y the same. Okay? And that would be D prime. Point E. X, y, 2, negative 4 is rotated 90 degrees clockwise. Where is E prime? Okay, so look at your rules. Your x, y becomes, if it is rotated 90 degrees clockwise, is going to be your y comes first. I'm going to pull it down here. Your y comes first and your x is opposite. So your y would stay the same, but it's going to become your new x on E prime. And then your x would be opposite of what the original is. And it would go in your y spot. Okay? Make sure your name and date are on these and turn them in.